Hi everyone, this video is on exercise 9F of chapter 9 PO2. So this is about differentiating a different trigonometric function, and honestly this part of differentiation is mostly about remembering some standard results, because that's by far the quickest way of differentiating these kinds of functions. And for this specific question, for each of these parts, we are going to use this standard result that whenever you have a function, let's say y is tan kx, then the derivative of this is going to be, so k sec squared kx. So this is the standard result that maybe the first one based on this exercise that we are going to use a lot. So yeah, let's see how we can use this. So for the first question, we have the function y is equal to tan 3x, and we want to differentiate this. So the derivative of that is equal to, if we just look at the result that I highlighted, this is exactly the same form. So basically the inside the bracket, the coefficient of x comes out, so 3 comes out, and then tan itself differentiates to sec squared. So here we write sec squared, and obviously the inside the bracket stays the same. So in this case, inside the bracket is 3x. Obviously I was writing kx. Yeah, so this is the derivative of this function. Okay, part B is more interesting because we have 4 tan cubed x. So this one is interesting because just to mention that here, this is the same as having something like this. So basically what this represents is that 4 times tan x cubed. So the reason I wrote in this form is just to remind you that you need to use the chain rule as well as using this standard result that we highlighted here. So again, this goes back to what I said earlier on previous videos, that in many differentiation questions we actually use more than one differentiation technique. As you can see here, we need to use 2 different techniques. One is more like remembering, and the other one is actual technique, which is chain rule. So in this case, dy dx is equal to, so just we use basically from chain rule, always the power comes down and we multiply that by the coefficient that is already there. So this is like the first step. And also, as a part of chain rule, the bracket stays the same as it is, but we reduce the value of the power by 1. In this case, 3 minus 1 is 2, and we differentiate the bracket itself, and that comes out. So tan x differentiates to sec squared x. Again, it's just based on the above result that I highlighted. So the bracket is tan x, but it differentiates to sec squared x. And as you can see, we can simplify 3 times 4 is 12. And then, yeah, we can't do anything further, honestly. Just maybe writing in a better form, which is tan squared x, and then times sec squared x. Again, it's common to get some results that you can simplify them, but you can just leave them in the form that you get. Right, for part C, we have y is equal to tan x minus 1. This one might look a bit confusing, but it's actually very simple, because again, this just goes back to the result that we have here. So you just differentiate inside basically, and then that comes out as your coefficient, and then you just also write then sec squared instead of tan. So in this case, by using that idea, so inside of the bracket just differentiates to 1, because x minus 1 differentiates to 1. So you can either write 1 or just don't write anything. Then tan differentiates to sec squared, so you do that, sec squared, and then the inside the bracket is always the same. then you can simplify this, which is x squared x minus 1. So yeah, this one was very easy. Now part D, this is probably the most interesting one. So we should be careful because we need to use the product rule here. We have x squared and then times tan half x. So we have two different functions. Okay, so let's differentiate this as usual. So we'll start with this part, and then when we use the product rule, so you always it's like, you know, you differentiate one function and you multiply that by the other function, and then you differentiate the other function and multiply by the other function. So in this case, just to show that without making you confused, we can start by writing down x squared. So x squared times the derivative of the second function. So you can write, it doesn't matter, the order doesn't matter. You can always start with the first function times the derivative of the second function and add to the derivative of the first function times the second function, or you can start with the derivative of the first function times the second function and so on. So it doesn't matter. In this case, I'm just going to start with the first function times the derivative of the second function. So the second function is tan half x, and the derivative of this, so inside, we always start with the inside. Half x differentiates to half, and then tan differentiates to sec squared. So sec squared, and inside the bracket is the same, but remember, it's a product rule. So the second part is now differentiating the first function this time, which is 2x, times the second function, which, you know, doesn't change. And now we can differentiate the last function, which is tan x minus a half. So that one, again, inside the bracket is x minus a half. That differentiates to 1. And tan differentiates to sec squared. Inside the bracket is just the same. And this is the final answer. So yeah, basically we have you know, 3 different terms. So one is this one plus this one plus this one. Okay, that's it for this video, and thank you for watching. Make sure to like and subscribe for the next videos.